So it's pretty much 9 o'clock. All right, y'all ready? All right. So good morning, guys. Courtney Sykes here. I hope you all are having a beautiful Tuesday. It is going to be nice weather today, so I'm always happy for that. So even if you have not done chemistry yet, you will. Or if you have done the chemistry chapters, then this is a phenomenal review because you're going to have to know this information for state board theory exam. And when I read a lot about what's going on today in the world and from esthetician students all over the place, it is actually pretty misunderstood that estheticians only perform practical things in school, right? That's very misunderstood. Not only do you perform practical items as an esthetician, if you want to be a good esthetician, a successful esthetician, then you need to understand the theory of everything exponentially. Theory is such a huge portion of this. So truly, guys, while we're under quarantine or whatever it is so important that y'all understand that the theory part of your role as an esthetician is so important. It is not all hands on, right? That's a very fun piece of it. And that is the majority of what we do. But you most certainly cannot perform your job correctly if you don't understand chemistry, if you don't understand ingredients, if you don't understand pH levels, if you don't understand sanitation. And I taught a 6-hour CEU class yesterday. 6 hours from start to finish. How fun was that? And it was so great because I actually went through the website for the Board of Cosmetology. We talked about sanitation, we did all this stuff, and it was a really great comprehensive learning moment for our alumni and licensed professionals all over the place. We even had people join us from other countries, so that was a lot of fun. But nonetheless, please remember that theory is so important to be an esthetician. It's not just about the practical stuff. It's not just about the hands-on items. Theory is a part of that, okay? So chemistry, here's what we're going to talk about today, guys. I hope you get excited because if you were interested in starting your own skincare line, what do you think you need to understand the most? Chemistry and understanding how products work together with actual active ingredients versus the vehicles versus the fillers versus everything that holds the product and suspends it into what it's supposed to be. So this is so important. This is truly very elementary chemistry education in my personal opinion, so it shouldn't be too crazy. And when you are on this chapter, it should be pretty easy to pass it, but I will tell you that this is going to be on state board, absolutely, okay? So here we go. Students at Southeastern Aesthetics Institute must understand how to utilize chemistry within their in-depth knowledge of aesthetics in order to treat their clients from a scientific and cellular perspective. Y'all know we say that all the time. From a scientific and cellular perspective, most certainly that's very true. All right, I love this, and I hope you can take a screenshot of this or take a picture of your screen, or of course, I will send y'all the recording of this today. The pH scale seems easy, and it is. It really is, but really understanding it as an esthetician is probably one of my more fun things to do. I actually love chemistry more now because, when we're talking about acidic serums or acidic chemical peels, I need to understand why something would work more aggressively than others, right? Or, of course, more neutral items. We'll talk about that. Basic or alkaline, the biggest thing you could just write down right this minute, if you don't already know this, is basic or alkaline products on the skin are pretty terrible. And here is why. Look at everything in the 10 and above, okay? We have ammonia, we have soapy water, so soaps, like detergent-laden soaps, drain cleaner. Those are very aggressive cleaning solutions oftentimes, and they're very stripping of the lipid barrier. And y'all have heard me say that before, but it's good to look at it from this perspective too. When you strip off the lipid barrier of your cells, you're going to either become more dry or more oily, depending upon what your DNA allows you to do, right? So with that being said, can you use, Dove soap, which is very alkaline, or can you use your Dawn dish soap, to wash your skin. That's also very alkaline. The answer is no. If you do that on your hands, even on your hands, you see that you become dry and cracked and just, it's not a good thing. You're wondering, well, where's my lipid barrier structure? Why am I not feeling hydrated? And it's because you are stripping that lipid barrier protection, and it's just not a good thing. When you start using that sort of thing on your face, initially you'll feel very squeaky clean, right? But it's not good. That is going to overproduce acne, overproduce oil, or overproduce dryness. It actually completely takes off the protective layer that allows you to shield yourself from environmental toxins or shield yourself from the sun. There's a lot of really good benefits to having a proper barrier on your cells, everywhere in your body, but especially your epithelial tissue, which is your skin. Okay. So look at your neutral points. That's great. Neutral is wonderful. I will tell you that's completely fine. However, when we get closer to the 5, 4, 3, 2, 1, that is what's going to create something called mitosis. So if you haven't fully held on to that fact yet, please remember that mitosis is what divides cells, right? And that is very important when you're talking about skincare, because if you have someone with very dull, lifeless skin, or you have someone with splotchy hormonal hyperpigmentation, if you have someone with post-inflammatory hyperpigmentation from picking at acne lesions over time, I see that often. You need to help them understand that, unfortunately, they're going to have to get used to dealing with some peeling as they work with you, as you help them align whatever treatment plan needs to happen so that they achieve their goals, right? They have to deal with that. So one thing that clients will complain about, they're either going to love it because they understand it, right? Or you're going to have people that say, oh, well, I don't like to peel, and I don't want a peel because I don't want to peel. And, I shake my head at that and say, okay, well, what am I doing wrong about educating this person? Because yeah, that's annoying, and we don't like to peel. And I know people don't like flaky skin. It's hard to wear makeup, and I get that. But there has to be some way for you to meet that client in the middle to explain why that's important, because it's going to be frustrating for you to help them achieve their goals in aesthetics if they don't do X, Y, or Z. And if they're not willing to receive chemical peels every so often, or to utilize acidic serums at home, you're going to have some real issues on your hands. And here's what the issues are going to be. The clients are going to start fussing because, well, why am I not seeing this result that you promised me? Or why are we not seeing, this outcome that you said we would get, And the answer is just that, because they're not complying with what you need from them. And so truly even having a picture of the pH scale, and not necessarily listing what all these other, examples are up underneath, but having them understand at least this very simple thing. Look at what it says in blue down in the bottom left corner. It says the pH of the skin is 4.8 to 5.5. It's that range. It's that range. If the client understands that, then they just truly have to understand how acids work with that in order to bring the pH level down to then create mitosis of keratinocytes. It will not work the opposite way. You cannot create mitosis of keratinocytes with alkaline ingredients at all. That will not happen. Don't even think it can. All right. So make sure you understand fully that pHs are a big piece of the puzzle. And I'll tell you, when I was in esthetician school, we didn't talk about pH levels. And I mean, that was in 2005. So remember that things have changed, and we can do things a lot easier now. We can help our clients a lot more effectively because we know more information. The education now is a lot better than it used to be, or at least I am going to make sure of that, right? So make sure you do understand that not only you need to get the pH scale, but your clients need to be the one to really understand this. Otherwise, they're not going to achieve that change and that new cell growth that needs to happen for what conditions, right? For deep lines and wrinkles, for people that have been laying in the tanning bed forever and look like a piece of leather, for people that have been laying in the sun and they have splotchy hyperpigmentation paired with hormonal hyperpigmentation, people that have eczema and psoriasis, they need new cell growth as well. What about people with acne grades 1, 2, 3, and 4? Everybody needs new cell growth. So getting people below the 4 is imperative. I highly recommend it. And if you yourself right now sitting here watching me think, well, Courtney, I know all about chemical peels because you've taught me this, but I've never personally had a peel. And frankly, I'm nervous about it. I want you to text me right this minute, because we're going to have a chat. I want to make sure you are comfortable with it. Even if you can do this at home, a very light, thin layer, I'll tell you exactly what to do. I'll walk you through the steps because you have to be comfortable with chemical peels. Chemical peeling is an essential part of change. If you can't help them with change, you're most certainly not going to have a client that's going to be dedicated to you for years to come. All right? Okay. This is the slide that I thought you all would appreciate. So take a picture of it, screenshot it, all this good stuff. So pH of products, need to knows for clients and estheticians. So I always talk about tiers of products, right? We talk about over-the-counter versus professional level. And then of course there's prescription level, which is not listed here because that's neither here nor there. That's just kind of additional items that they would utilize in addition to professional products. Because remember, professional clinical grade products that estheticians would recommend are going to be what people need to use all the time. That's where people need to live, right? So let's look here. And again, have this visualization of the pH level in your head as we're talking about it. Anything below a 7 is going to be considered acidic. Anything above a 7 is going to be your alkaline, which is no good. And Alasia, I see you, girl. I'm going to make sure you're comfortable with peels. Okay. We're going to make sure you are. We are. Okay. So look at the left, pH of your over-the-counter products, and you can tried and true test this on your own. You can go to Lowe's today, the home improvement store, and pick up some pH tests that you would use for a swimming pool. All right. And you can test these items. So remember, nothing can be anhydrous, so no oils can be tested appropriately for pH levels. Just something that has water in it can, which all these examples would. So look at the cleansers under over-the-counter products. If it's going to be in a pH of 8 to 10, what is that? That's going to be considered to be alkaline. Is that good for your skin? Not really at all. That's going to strip the lipid barrier. So you've, started your skincare routine that night or that morning on a bad note anyways. You've thrown your pH level off really crazy. So you may as well just not do anything else. Your serums aren't going to penetrate very well if you've thrown your pH level to be very alkaline. Listen to what I just said. You cannot do this and piece it together with over-the-counter and clinical grade products and expect to still receive clinical grade results. You cannot. Look at the cleansers in the professional category. So cleansers in the professional esthetician grade category are typically going to be between a 6 and a 7. That is a great thing. And here is why. When you have cleansers in a 6 or a 7, your skin's like, this is good. No big deal. I'm feeling nice and just even toned, even pH, nothing crazy's going on. So if you notice too, down the line there of cleansers, acidic serums, and nourisher serums in the professional category, nothing goes over that 7. Remember that nothing should go over that pH of 7 ever, and your skin's going to be so happy with you. But I promise you, if you can figure out what clients are using at home that's causing them not to have the results that you really prefer them to have, or that you think they should have at this stage in their treatment plan, that is most likely one of the issues, is that they're using something that is very alkaline or something that's not acidic enough. Like I've told y'all before, a lot of folks love they're nourisher serums because they're not harsh, right? They're not going to cause peeling and, flaking and all that kind of stuff. People are inherently a little nervous about acidic serums because they don't like the tingle, they don't like the flakiness, but that is truly a sign of you getting great results. Even if you just do your acidic serums twice a week, that is way better to me than you just living in this zone, this safe zone. You have to kind of push it off the edge a little bit in order for it to change. Then you can start using your nourishing serums again, and all is good. Okay, so we've identified cleansers over the counter. Wah, 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 right? Not good. Your cleansers professional level are great. 6 and 7, between a 6 and a 7. Life is good. We're having a party. Our skin is happy. Okay. Now let's look at acidic serums on both sides. Your acidic serums that would claim to be as such, I've got a lovely little example for you on the next slide that is a branded item that you're all going to know. Acidic serums on the over-the-counter lineup here are between a 4 and a 7. While that's not horrible, it is not the best. If your skin is a pH of 4.8 to 5.5, are you really getting results when it's staying between a 4 and a 7? No, because we're not actually bringing the pH down below 4, and that is doing your skin a huge disservice. And technically, and I'll show you why you can probably just see why it would be kind of that way without even testing it. I'll show you on the next slide. You're going to be blown away. Then pH of your professional products on the acidic serum standpoint, look at that. It's going to be between a 2 and a 4. Isn't that much better when it comes to actual science of your skin being broken down in order to create mitosis to build new cells up? If people are unwilling to do what it takes to have gorgeous, fresh, new skin, and that includes chemical peels and acidic serums, then they're most certainly not going to get the results. And that would be the very first thing I would tell a client. So if you have client Jody over here and she's coming to you and she has deep lines and wrinkles from laying in that tanning bed forever and ever, I'll say, okay, Jody, I know you don't like, chemical peels, or you've said you don't, and I respect that, but let me tell you something. If you're going to come spend your dollars with me, you're going to need to allow me to help you feel safe with peels. I promise you we can ease you into it. You will love the results. I will help walk you through, and I promise that you will be just fine. Just trust me. Please trust me, because I want you to get the results that you're coming to me and talking to me about right now, because what I listened and heard you say is that you're concerned with deep lines and wrinkles, right? And she'll say, well, yeah. And you will then say, okay, well, we have got to build you up into acidic serums and chemical peels to create new cells. That is the only way to do this. And I promise you, I will help you through the whole thing. And you will come to love chemical peels, and you will understand how to use acidic serums at home to where you're not having those aggravated skin issues or whatever the case may be, because we're going to alternate it, or we're just going to use it a couple of times a week. And then she'll say, okay, well, that sounds really great. You have to help people understand that fear is just a mindset. They can overcome that. You can help them achieve their goals if they will just allow you to assist them in trying that thing that they were fearful of, right? So acidic serums and chemical peels, I would just put that in your notes as something that clients just inherently are a little nervous about for one various reason or another. But you can educate them in such a way to where they will be just fine. It's all about education and all about just jumping in and trying it sometimes, All right, then your pH of over-the-counter products when it comes to nourisher serums are usually going to be pretty alkaline, and that's not great. And the reason why that is you're going to have a lot of your cheaper binders and fillers that are going to be surrounding your active ingredients. It's just simply going to be alkaline no matter which way you look at it. Those very nice active ingredients will also not penetrate to where they need to go, so it's just more or less a marketing ploy anyways. So keep that in mind. time. You know, you guys have learned a lot of the ingredients from me already. If you need a good review on ingredients, you know, and of course, I assume you have that ingredient knowledge based on things we've discussed over the past couple weeks, please go back to our YouTube channel, rewatch some of my videos, you know, about ingredients. And in that way, you'll feel like all this cohesively comes together. Then the Nourisher serums on the professional side. And when I say Nourisher, remember what that's supposed to mean. Your Nourisher serum should be things that build cells up. You know, your vitamin C's, your antioxidants, your peptides, your hyaluronic acid, things of that nature, correct? So that should be between a 4 and a 7, which it will kind of hug your pH where it is. You know, your natural skin pH is going to be 4.8 to 5.5. So that's not going to disrupt the lipid barrier. It's most certainly not going to break skin cells down because it's not designed to do that. So the pH should be between a 4 and a 7. I hope y'all like that slideshow. And even if you typed up something like this and put in a little acrylic display on your consultation counter, this would be so important because clients need to understand this. And this would be a fun little activity for you to do with your clients. Okay. All right. So pH of products need to know for clients and estheticians. Reminder, and this is your reminder, active ingredient examples of acids and nourishers. And if you need a bigger review, remember, go back to my other YouTube videos. AHAs, BHA, retinol, benzoyl peroxide, hydroquinone, those break skin cells down. And then you have your nourishers like ascorbic acid, hyaluronic acid, stem cells, growth factors, peptides. Remember, ascorbic acid is also your vitamin C, right? Those build cells up. Okay, now look here. Notice the pH of professional products does not go into the alkaline or basic zone, which we've said. This just confirms that. Acidic serums must be the pH of our natural skin or lower in order to create change. Woo, write that down. You might want to put that out on social media today. I would take a picture of any acidic serum you have and say, look, folks, you know, we're focusing today in our education on acidic serums. What are you doing to achieve change in your skin today? Acidic serums must be the pH of our natural skin or lower in order to create change. And by change, I mean mitosis, splitting of cells, division of cells, creating brand new cells. And life is good, but that has to happen. Cleansers and nourishing serums are ingredients that build cells up, must be the pH of our skin or higher, up to the neutral zone in order to effectively treat cellular health. So pretty much, remember, nothing should go above a 7, and that is an easy way to remember professional grade products, and it is a fun activity to do when you are looking at products and deciding what is good for you, what's good for your client, and all of that. Now, I thought you would love to see this. Woo! Take a picture of this one or screenshot this. Place this all over social media today and tag me in it because I love stirring things up with people that think they know stuff. And I'm sure you do too, because listen, knowledge is key, right? Look at this. Let's compare, shall we? Ingredient listing. So this is supposed to be a product, obviously, from Neutrogena that is a retinol cream. They call it the Rapid Wrinkle Repair, and they market it to be a retinol product. I mean, look at the box right there, guys. Look at it. It says accelerated retinol. Well, there's nothing accelerated about that retinol product, is it? Because look at where the retinol is located. It's located at the bottom. What do we know about ingredients that are supposed to be active ingredients? We know them to be items that have to be in the first pretty much 4, 5, 6 ingredients in the product label. And I say 6, probably stretching that out a little bit. It needs to be at least in the top. Let's look at some of these other ingredients as a review. Of course, it's got water as the very primary ingredient, and the FDA, of course, requires that you place ingredients in the label from the most to the least percentage. So you're always going to see the most concentrated ingredients at the top. So, of course, it's mostly water, so they're paying for water, right? Dimethicone. Remember dimethicone is a silicone-based ingredient. And here's how you can remember that. Silicone dimethicone. It sounds similar. So what it is, and I actually like dimethicone very much, but not as an active ingredient as you see it here. Dimethicone, I bet you the way this product feels is like the way a makeup primer feels. Do y'all have makeup primers at home? Primers feel very silicone-like, don't they? Very silky. So I promise you, with my knowledge of what dimethicone is and what it feels like, I bet this feels very primer-esque, which unfortunately will actually buffer down any effects of any sort of acid like that retinol way down there at the bottom. So you're really not getting a delivery of retinol at all. It probably feels good going onto the skin, and that's pretty much about it. You see this starch, octanol succinate. That's just, you know, it's an aluminum starch, nothing too crazy there, probably just kind of buffers it a little bit. Another dimethicone, another ammonium copolymer, let me think if I can say this one. Trisiloxane. Okay. I've not seen that one in a while. That's just, you know, more or less a binder filler. You've got alkyl benzoate. That's a binder filler. Ascorbyl glucoside. That's a sugar molecule of some kind. Glucoside, glucose. Glycerin. You can write down glycerin. I'm not, you know, against glycerin. I actually like glycerin most of the time. It would be better if glycerin were actually at the top. Glycerin can be a hydrator. It's also a carrier in a lot of products. You will see that. There's nothing wrong with glycerin. That's not a bad product. But again, your active ingredients just simply aren't at the top here. You have got polyacrylamide. That's interesting. Anything acrylic specific, like what you have in your adhesives for your eyelash extension adhesive, polyalkyl methacrylate, I bet that's in the same family. That's not necessarily great for your skin, I will tell you, because anything acrylic wise is definitely going to be almost glue-esque. So I would say that's probably not the best thing. Xanthan gum is placed in products to thicken it up. That's also not the worst thing in the world, but it's usually towards the bottom and not in the middle of a product. Fragrance typically is not great either, unless it's from natural essential oils or something like that. Fragrance is very synthetic and can be very irritating to people's skin. Isoparaffin. Anything paraffin, have you ever had the paraffin dips at the nail shops or anything? Paraffin's a very thick ingredient, and I promise you that's also just simply going to be something that does not allow ingredients to penetrate very well. Anything that thickens up a product will cause it to be buffered, and by buffered I mean it's just going to sit something right on top of your skin, and so the delivery system, in my personal opinion, just simply isn't there with this product. Sodium hyaluronate, we recognize that one, don't we? That is a synthetic form of hyaluronic acid which binds water to your skin. Totally not a bad product. We love sodium hyaluronate, but it's in the middle, if not close to the bottom of this ingredient label. So I will say that the effects of that are probably slim to none. You also have got a leaf extract, not a problem there. Sodium lactate, that's some sort of a milk-based lactic product. Nothing wrong with that. Sodium hydroxide, interesting that they placed that in there. Then let's see, polysorbate 20, disodium EDTA, those are all binders and fillers that actually aren't good for your skin. And one thing that I see in here too that I do not like is mica. Mica is a very cheap ingredient that is actually causes like a sheen or a shine, and you'll see it in a lot of your cheaper eyeshadows. Definitely not something I would want in a skincare product. I'm not quite sure why that's in there either. And then titanium dioxide is a sunscreen ingredient. I'm not sure why that's the very last ingredient in there, but of course, none of that actually does a whole lot. So very interesting combination of ingredients. I'm not sure why they did it this way, but I will tell you one thing I learned when chatting with my lab, and one of the newer contacts I have with my lab, she's a little bit higher up on the totem pole, and she was chatting with me because I like to custom blend formulas. She said, well, you know, what did she use? She used some sort of funny analogy, and it really stuck with me because this is companies like this right here that ask labs to do things this way. She said, well, do you want things to be, you know, do you want your product to be clinically sound, you know, results oriented, or do you want it just to be for marketing? And she said it better than that. And I thought to myself, I said, well, hello, why is that even a question? It should always be clinical. It should always be results oriented. What do you mean? And it just made me realize right then and there, this is what she's talking about. There are companies out there that want marketing level active ingredients, which this would be a firm example of that. This means that because it's got retinol in it, they can legally market it to be a retinol product. But that doesn't mean that it's actually going to deliver retinol into the skin and actually work. Isn't that the saddest thing you've ever heard? I'll repeat that one more time for those of you that didn't hear me. There are labs out there that can do this, and they do it all the time for product lines like Neutrogena that want probably a cheaper cost per SKU so they can make more money, right? What will happen is they can actually ask the lab to do more marketing specific active ingredients in a product, which means that they can market it to be a retinol product like you see here, but it's not actually going to deliver any results for the client or in the skin. And I think that's pretty crappy for companies to do, but it happens all the time. So if you weren't an ingredient list lover, you will be now. Even if you don't know the definitions of a lot of things, just shoot me an email, shoot me a text. I have alumni that text me every day from years ago that ask me questions. So please, please, please ask me if you have a question about a product, because I love to dispel myths about products. And this is so eye-opening sometimes. So send me some pictures, actually. Text me some pictures of something you have at home, and let's really, you know, dissect it together. And I'll post it on our student and alumni page so we can talk about it and look at the ingredient list and see, you know, and answer the question, does this product actually work? You know, does it actually work? Does it do what it says it's going to do? You know, we will figure that out oftentimes by looking at the ingredient label. Then this is a better version of a retinol serum. And I love Glow Skin. I hope y'all had hopped on the line with the Glow rep last week. She was, of course, going through a bunch of different things with you guys, I'm sure. But this is a retinol smoothing serum. Let's look at what it's got in it. First thing that's in it is witch hazel water, which is not a bad choice. And I'll say why. I'm not a huge fan of witch hazel because most of the time it's just simply paired with alcohol, which means it's very, very stripping of the lipid barrier. But this has other things in it, which makes me a little bit, you know, less concerned. So we have our witch hazel, we have water, we have alcohol. So that strips everything down, which to me is good for what this product is delivering. So what is it delivering? Look, we have glycolic acid next. So you've kind of stripped the skin a little bit with alcohol and witch hazel to deliver glycolic acid, which produces new cells. We know that. Then butylene glycol is a binder filler. Nothing wrong with that. It's okay. Glycerin, we talked about that one. That's more of a hydrator, but in this instance, most likely a carrier / hydrator. We have retinol in the top, so that's great. So that speeds up cell turnover. So this truly, to me, does say it's going to do what it says it's going to do. You've got a carrot seed extract, you've got a cucumber extract, you've got a tomato fruit extract. So I will tell you that kind of stuff probably gives you a better scent that's more of a naturally derived scent than just simply including fragrance, right? Then you have a flower extract, you have xanthan gum, which thickens it up a little bit, and that's okay when xanthan gum is at the bottom. You just need like a little bit in a product sometimes just to thicken it up, and that actually helps with safety of delivery systems of retinol to some extent, so I'm fine with that being where it is, you know. Then you have a bark extract, which is great. for just kind of skin clarity, all that good stuff. You have another carrot seed oil, which is really cool. So there's a lot of really great ingredients in here. I have nothing wrong to say about this. This would be a perfect example of an esthetician grade retinol product. And what I do love about an esthetician grade retinol as opposed to a prescription grade retinol. Esthetician grade retinol products simply give you a good, even distribution of retinol, whereas prescription grade retinol tends to be really, really harsh. So people that want like a nice retinol that's not going to peel their skin crazy, they would want to get on something like this, right? So who needs retinol is probably a question that you would ask. And I would say anybody that has that issue, like we were just talking about the client Jody that has very thick, leathery looking skin from laying in a tanning bed, she would be a phenomenal example of somebody that would need a product like this. And you could alternate it with some lighteners and brighteners like kojic acid serums or arbutin, hydroquinone serums, things like that, to get rid of the sun damage. But this is going to help shed the skin and also produce new cells in conjunction with whatever else you have the client on. So you see why one product just doesn't do everything. You know, you need something to turn cells over. You need something to actually create new cells. You need something to treat the hyperpigmentation. You need something to treat the acne, you know, that sort of thing. So just food for thought. Okay, now we're going to get into the vocabulary words, and I will make sure to go through this relatively quickly. But for those of you that have not had this, this is a phenomenal education on this with pictures. But then if you have had this, you need to know this for state board. Don't ever think that while you're in school that you know it all, because I promise you, you do not. Until you have passed and you are licensed, you are not an expert yet. We always have something to learn. So let's look at this. Solute versus solvent. Solutes, solvents, and solutions. Let's talk about it. A solvent is a liquid that dissolves a solid, liquid, or gaseous solute. Okay. A solute is a substance dissolved in another substance. Then a solute and solvent make up a solution. And I just like the picture off to the right, really, because all these words are S words. So it can be a little confusing that way, but I promise you it's okay. And we will make sure that you understand it. It's just kind of taking some of those words and maybe drawing a picture off to the side of your test and saying, okay, the solvent's going to be more of the water that dissolves. The solute is what is being dissolved. And then together they form a solution, right? Easy enough. Okay, then matter. Of course, this picture off to the side is probably way more complicated than necessary, but this is so easy. Remember this, guys. Matter is a substance that has inertia and occupies physical space, such as a solid, liquid, or gaseous substance. I like that word, inertia. That sounds really neat to me. But remember, a solid, liquid, or gas. And one thing I want you to look at off to the right is matter as it goes into these different categories. We have states of matter, which we just talked about, solid, liquid, or gas. Then we have the purity of the matter, whether it's a pure substance or an impure substance. When you look at pure substances, I'm really looking at more of what's on the elemental table. You know, is it an element just like, you know, oxygen or hydrogen or nitrogen, or is it a compound such as H2O, right? 2 elements of hydrogen or 2 atoms of hydrogen, 1 atom of oxygen. You know, that would be a compound. Or is it an impure substance, like a mixture? Is it homogeneous or is it heterogeneous? Those are some things to think about there. Homogeneous means, if you see what it says there, also called a solution, constant composition throughout the mix. Okay, so examples would be salt water or air or even brass. Heterogeneous would be to the eye, can have variable compositions throughout the mix. So those are things you might want to know, not going to be on your test, just kind of a neat point there. And then changes of matter are additionally important. Is it going to be a physical change or is it going to be a chemical change? You know, so physical changes would be water turning into ice. The only thing that changes is the temperature, but the actual physical part of it is still the same. It's still H2O. Whereas chemical changes would be a lot different. Whereas metal turning into rust, it takes one, combination there and turns it into a completely different chemical compound. So that would be more or less a chemical change. Okay, so look at what it says here. We just said this. So physical changes can be observed without changing the identity of the substance. So luster, melting, boiling points, density, solubility, odor, phases of matter. That doesn't mean it's going to change the chemistry of it. It's still going to be the same actual physical piece of what it is. So examples would be ice versus liquid. Water is still H2O, physical change. Chemical change can only be observed by changing the identity of the substance. That's a really good definition. It changes the entire identity. So flammability, ability to rust, pH, toxicity, combustibility, reactivity to water, air, or acids, etc. Those can change the actual chemical composition of matter. So examples would be metal turning into rust. There's plenty of other examples out there. Okay, so the question you might have, what is the chemical reaction for rust? It turns out that what we call rust is a chemical process that combines iron and oxygen to form iron oxide, folks. Thus, by studying rust, we are studying chemistry. What is happening? During this reaction, the iron atoms are passing electrons to the oxygen atoms, a transfer that is called oxidation. Now, do you need to know this specifically like this for boards? No, but you do need to know what oxidation is. And oxidation is the introduction of oxygen and the reduction of hydrogen. If you really want to know, and if you do, then that's great. You might want to write that down. That is something that will be on state board. So rust consists of hydrated iron oxides, Fe2, and then one O. So 2 atoms of iron and 1 atom of oxygen. Okay, so if you do want to write this down, please remember oxidation. That's a big one that you do need to know aesthetically. It's in your textbook. And here's what it is. Oxidation is the introduction of oxygen, the reduction of hydrogen. Okay. Look at this beautiful table of elements. I have this slide in another lecture that I give on the scientific theory of lasers and all of that good stuff. So there's all sorts of fun things on here too. I wish I could find some of them. Let's see. Look at the bottom. There's some neat mediums. Oh, there it is. Holmium, erbium, CER, that's number 68. Those are actually mediums for lasers. So if you really want to know what laser light actually passes through, oftentimes you have these very rare elements inside the laser itself, and it bounces through all these different mirroring systems. And erbium lasers are so popular. So if you didn't know, that was actually part of the table of elements. Where is yttrium? Yttrium is somewhere on there. I can't find it. But nonetheless, this is actually fun as an adult. I remember learning this in high school and probably not caring too much about it then. But the table of elements is really neat. And there's actually something I want to purchase that it's a table of elements display that has examples of each, which I thought was super cool. I'll have to purchase that and bring it to the classroom. Thought that would be neat just to kind of get a visual of what a lot of this stuff looks like. Okay, then your next one, what is an element? Each of more than 100 substances that cannot be chemically interconverted or broken down into simpler substances. So it's just essentially a substance that cannot be broken down into simpler substances. Each element is distinguished by its atomic number, which is the number of protons in the nuclei of its atoms. How about that? So remember how we learned about your cells, and your cells have your organelles that sit in the cytoplasm. You have your nucleolus, which houses the nucleus, but within that, it has the number of protons within the atom. So a hydrogen atom just has 1 proton in the nuclei. So that's kind of neat to remember or think about. Nothing you're going to be tested on. You just simply need to know the definition of an element, but so cool if you really love science like I do. What is a compound is the next one. It's made up or consists of two or more elements. So look at hydrogen, for example. You've got 2 atoms of hydrogen, okay? Then oxygen, 2 atoms of oxygen. Chlorine, Cl2, 2 atoms of chlorine. So those are compounds, okay? Made up or consisting of 2 or more elements. Look at sulfur. Sulfur is big for acne clients. Sulfur masks are really popular. Then what is a molecule? It's a group of atoms bonded together representing the smallest fundamental unit of a chemical compound that can take part in a chemical reaction. So we know water is H2O, but you see how they're linked together and they're 2 different elements. I think that's the biggest thing to understand. So you have a molecule which is bonded together in order to create a chemical compound. All right, just thought these pictures were kind of fun and 3-dimensional looking. So you see sulfur there again, fluorine, chlorine, bromine, iodine, very important. Thought that was neat. So let's chat aesthetics. What is the chemistry makeup of glycolic acid? Now, I put together this slideshow maybe 2 years ago now, and these are actually questions that I just really wanted to answer because I thought you would be interested in it. Again, not on your test or anything like that, but if you understand the hard stuff, guys, you're going to understand the easy stuff, right? So just fun information. So let's read here. Glycolic acid is a small molecule hydroacetic acid that's colorless, odorless, and hygroscopic. These properties make glycolic acid a suitable ingredient for keratolysis, which just means exfoliation, and anti-aging applications, which is the stimulation of tissue production and hydration. Glycolic acid is also water soluble, making it versatile for dermatologic and cosmetic formulations. So that's why glycolic acid is so popular, is water soluble, can be used easily in products if, of course, utilized closer to the top of the ingredient label as we discussed. But gosh, I thought this was neat. So you might want to take a screenshot of this one, so people know it's actually C2H4O3. That's glycolic acid. Who knew? And that's what it looks like right over there. All right, then the chemical name is 2-hydroxyethanoic acid. Not going to make you say it quite like that, I promise you, but the molecular formula is this. It's a carboxylic acid substituted with a hydroxy group on the adjacent carbon. I know that sounds very convoluted, but just fun information. Nothing you're going to be tested on. So again, glycolic acid is your C2H4O3. So what is it made up of? 2 atoms of carbon, 4 atoms of hydrogen, 3 atoms of oxygen. How about that? So then, general manufacturing. Glycolic acid is derived from sugar cane and sugar beets. So your question might be, you know, why is glycolic okay to use on pregnant women? This is why. It's actually derived from natural sources. So that might be a test question eventually. You know, where's glycolic acid derived from? Sugar cane primarily. Sugar beets, you might read that sometimes, but sugar cane, you'll see that in your textbook. It has also been commercially synthesized by direct reaction of chloroacetic acid with sodium hydroxide and re-acidification. Don't worry about that. I'm just reading and showing you some fun information, but look at what it says. Manufacturers can utilize a fermentation-based biochemical process to synthesize, so synthetically create, varying grades of glycolic acid. I thought that was neat. It's supplied in either liquid or crystalline form. This is what makes me want to work in a lab and just have some fun with stuff, right? It can be supplied in either a liquid or crystalline form because you can synthesize various grades of it. I thought that was really neat through fermentation. Glycolic acid is available in varying concentrations and grades depending on intended use. Industrial grade glycolic acid used at a greater than 70% concentration is considered non-volatile hazardous material for rust removal in textiles. How about that? So when you think of a volatile ingredient, I think of alcohol because it evaporates quickly. So when they say non-volatile, it does not evaporate quickly. So non-volatile hazardous material for rust removal in textiles. Neat. Pharmaceutical grade glycolic acid undergoes a complex series of filtration and purification processes. Thought that was neat for you to know too. For skin applications, glycolic acid is used in concentrations less than 70%, absolutely, with clinical use above 50% concentration. Yes, so we have that available, but most of the time, you know, estheticians will use 15% glycolic, 30% glycolic, that sort of thing. The pH of the product can be buffered. Yes, we've heard that already. Then it goes on to say, the peeling effect of glycolic acid has been demonstrated using high concentrations, okay, and low pH formulations to promote keratolysis, which just means shedding, the separation of the epidermal layer, all right, from the dermis through accelerated cell loss. The mechanism behind this effect is a weakening of the intercellular corneocyte bonds that disrupt the adhesions of corneocytes, remember those cells at the top, in the lower stratum corneum, causing a separation of the bulky upper layer from the newly formed lower layer. So I thought that was just neat for you to know. So it helps to separate the epidermal cells, you know, and that's of course what we know that it does, but it's neat to look at it from that perspective. I thought that was cool. So not on your test, just fun information. All right, so here's some test questions you might have eventually. What has physical properties that we can see, smell, taste, and touch matter as the answer? That makes sense. What causes oxidation? I told y'all this already. The addition of oxygen or the loss of hydrogen. A good example of that would be how benzoyl peroxide is introduced into the skin. So when you think of benzoyl peroxide is an oxygen molecule. So you have your skin, and let's say that we're going to introduce, you know, benzoyl peroxide here. What's happening is it's creating oxidation. It introduces oxygen, but in the same token, it loses hydrogen. That's how I remember how oxidation works, is that benzoyl peroxide example. And oxidation is actually not good for your skin, which is why I'm not really a huge fan of benzoyl peroxide. I do like it if you need to use it for grades 3 and 4 acne, but just for short periods of time, because it causes oxidative stress, which is a free radical inducing sort of chemical reaction. So not good as one would think. Just think about that. What is an atom with a positive electrical charge? You might see this truly on your state board exam. So the answer is a cation, okay? A cation, if you're asking what the question is, you see that here is a positively charged ion. So, for example, a sodium ion and an ammonium ion are cations. They're positively charged. So just try to think of ways to remember that one. That might be on your exam, okay? Then, let's talk about what miscible versus immiscible means to answer this question. So, miscible just means mixable. Immiscible means not able to be mixed. Why would they just not say mixable versus non-mixable? I don't know, but it is a scientific term, and I just want you to remember that immiscible means it's not able to be mixed. So, what is united with the aid of an emulsifier to create an emulsion? And this is truly where I would draw a lot more on the board to talk about things like surfactant molecules that is probably going to be coming up in just a minute. But the answer is 2 or more immiscible substances. So what is united with the aid of an emulsifier to create an emulsion? So remember, an emulsion is something that can be emulsified. You know, it just kind of congeals together. When they're talking about an emulsifier, they're actually talking about something called a surfactant. And don't worry if you've not learned this in the classroom with me, because we will go over this again. This is just really good information for right this moment. But 2 or more immiscible substances like oil and water, they're not going to mix naturally, right? You have to unite it by the aid of a binder or emulsifier, but what that is actually called a surfactant molecule. It has a water-loving head and a oil-loving head, so hydrophilic versus lipophilic. So just remember, that's how an emulsion is created. You have to have these other ingredients other than, you know, immiscible substances to have things congeal together and have some sort of shelf life oftentimes. So the question on this one is, what is a solution It's actually a uniform mixture of two or more mutually miscible substances. So they're mutually miscible, and that makes sense. If you're going to have something that's a solution and they're suspended in one another nicely, they're definitely going to be miscible substances, meaning they're going to mix. So that should make relative sense for sure. Then what is true of elements, guys, we said this already, elements are the simplest form of matter, right? So hydrogen, oxygen, we talked about yttrium, aluminum, some of those laser ones that I think about a lot of times, or erbium, right? Those are just simplest forms of those pieces of matter, simplest form of matter. What term refers to molecules that contain two or more atoms of the same element? So two or more atoms of the same element, this would be an elemental molecule, and your example would be H2. So two atoms of hydrogen would be an elemental molecule, two or more atoms of the same element. Easy enough, right? What is the difference between water and oil emulsions and oil in water emulsions? I hate this question because it seems very confusing and I don't really like the answer, but this is a book question and answer. The answer is emulsions of oil and water. I don't like that. Of course it is the answer, but I don't like that question. If you see a question like that on State Board, and I highly doubt you will, just the way that this is asked, this is from the Milady book. What term means water loving? The answer, when we were talking about the surfactant molecule, remember it's got a water loving head and a oil loving head. Your water loving head is hydrophilic, right? Hydro meaning water, okay? And then oil loving, that side of it, lipo means oil. So the word lipophilic makes sense that it means oil loving, okay? Then what are suspensions, guys? Suspensions is when you look in the refrigerator and you look at that Italian dressing and everything is separated, right? So suspensions. It's a uniform mixture of two or more substances. Suspensions contain larger particles than solutions do. Suspensions have a tendency to separate over time. And that's okay in some circumstances. I'll tell you another good example of a suspension in the aesthetics world would be your neutralizer. And I have an example of that right here, actually. If you have done services in the school, you have utilized this Glow Skin neutralizer before. And what it's got in it is calcium carbonate. In calcium carbonate, if this was a clear bottle, you would see that it settles down at the bottom. So you actually have to shake it up really well because it is a suspension. Then you're going to, dispense it onto a gauze or whatever the case is that you want to use. But that is a great aesthetics example of a suspension. So just keep that in mind. You do have to shake up things like that are suspended. And oftentimes you do have to read that information from companies. I remember having to ask that question years ago about that product. So look at what it says here. What are suspensions? A suspension is a heterogeneous mixture in which solute-like particles settle out of a solvent-like phase sometime after their introduction. We use the terms solute-like and solvent-like because we are dealing with a heterogeneous mixture, while the terms solute and solvent refer to homogeneous solutions. We apply the word suspension when particles are big enough to eventually settle, right? If the particles are too small to ever settle, they are said to form a colloid. I just thought that was good information. I love more than just the necessary information, as you can tell. So examples of suspensions, I thought these were neat little examples as well. Sometimes in the right light, you'll be able to see particles of dust floating in a room. Eventually, the dust will settle on the floor and on furniture, and the room will need to be cleaned. Dust in air is a suspension. How about that? Example 2, if you go to a beach and mix sand and water in a bucket, you'll form a suspension, won't you? Given time, the sand will settle on the bottom of the bucket to leave clear water. That is very true. That's another good example of a suspension. The next one is, what is any substance that is dissolved by a solvent to form a solution? You'll definitely probably have that on State Board for sure. Solute. The solute is a substance that is being dissolved by another substance, okay? That's the answer. But to give you the definition again of a solvent, the solvent is a substance that dissolves the other substance. So remember back to that picture in the beginning where the water solution is more of your solvent, or no, your solute. No, solvent. I'm confusing my own self. It's the solvent is the substance that dissolves the other substance. The solute are the particles within it that are being dissolved. So just keep that in mind. Then this is another question you'll have on state board too. What is the study of substances containing carbon? The answer is organic chemistry. Inorganic chemistry is the study of substances that do not contain carbon, basically the opposite of this answer here. So just remember, organic chemistry contains carbon and you are all good, okay? Oops. Too far. What are the two branches of chemistry? We said this, organic and inorganic chemistry. Easy enough. Then here's some good examples on that. I thought this was a neat just picture with just some interesting information. I will make sure you have a copy of this so you can look at it on your own. Then this question, put a star by it. This throws people off like you would not believe because you won't see it, but just this one time. This will be on state board, and I don't want you to get this wrong. The question is going to be, how much of the air is made up of nitrogen? Seriously, put a star by this. I'm not kidding. Right? Dry air is primarily made up of 78.09% nitrogen. Right? We think of the air mostly being made up of oxygen that we breathe, but dry air is primarily made up of 78% nitrogen, folks. So make sure you remember that. That will be on state board. Do not forget it, okay? Then what type of substances have a pH level of 7? They're going to be neutral substances. Pure water is an example. What is reduction? So, if oxidation, guys, is the introduction of oxygen and the removal of hydrogen, this is actually going to be the complete opposite. What is reduction? It's going to be the loss of oxygen or the addition of hydrogen. So keep that in mind. You're going to see this redox reaction thing as well. So read with me what it says in the green words, okay? An oxidation reduction reaction, also known as a redox reaction, is a type of chemical reaction that involves a transfer of electrons between two species. An oxidation reduction reaction is any chemical reaction in which the oxidation number of a molecule, atom, or ion changes by gaining or losing an electron. Do not get overwhelmed by that. Just know that I'm going to teach you redox reactions a little bit more in detail in the classroom. But if you'll just remember, oxidation is the introduction of oxygen and the reduction of hydrogen. Reduction is the introduction of hydrogen, the loss of oxygen. So just remember, and then together cohesively, it can actually form a redox reaction. So we'll get into that more. This is just a good review. Alcohols. We actually did this not too long ago. Alcohols are not all made the same, I will tell you, but we won't go into that right this minute, but there's different alcohols you might use in certain products versus others. But what is an alcohol? It is any organic compound whose molecule contains one or more hydroxyl groups attached to a carbon atom. So what you're going to see there, look at what that example is. Methanol, CH3OH is the most simple alcohol molecule, which is kind of interesting information. If you see OH on the end of something, that is most likely always a alcohol product or ingredient. So just keeping that in mind. Just keep that in mind. Let's read on what it says here. The category of the alcohol is classified as 3 groups, which are primary alcohol, secondary alcohols, and tertiary alcohol. If the alcohol bonded to one alkyl group, the alcohol is primary alcohol. The secondary alcohol is defined as the alcohol which one of the carbons is bonded to 2 alkyl groups and 1 hydrogen atom. If one of the carbons is alcohol, in alcohol is bonded to 3 alkyl groups. It is called a tertiary alcohol. So don't worry too much about that. That's just additional information I wanted you to see. But alcohols are very, very prevalent in a lot of products. You don't want to have a ton of alcohol in a product, and it's not always there just to be a dryer or a stripper of your skin. Oftentimes it can be a carrier or a binder or filler, within the product itself. So very, very popular. And I highly recommend you kind of look some of those examples up today on the internet and look up different skincare products all over the place, over the counter versus clinical grade, that have alcohol in the ingredient label. There's a bunch. These are some examples. So when you're looking for things, you might see this in a longer term, to be quite honest with you, but you'll see something that says ethanol or, hexanol, pentanol, just different things. So the formulas are a little bit different, as you can see there, and it will just kind of give you that thought process of what to look for. Okay. Now, this confuses the heck out of people, but this was in our advanced book, not in your fundamentals book as it states now, so don't worry too much about this. But the question is, what are polymers, proteins, and peptides? Okay, all P's. By definition, polymers are large molecules made by bonding a series of building blocks. The word polymer comes from the Greek word for many parts. I thought that was neat information. Proteins are made up of hundreds of smaller units called amino acids, which we know. They're attached to one another by peptide bonds. We love peptides, don't we? That chain link fence that tightens everything, forming a long chain. So peptide bonds are essentially proteins, right? So when we're thinking about, chemical, chemistry of peptides and what is a peptide, why do I need to use it for anti-aging, is creating a chain link fence of peptide bonds, which are essentially proteins, which those are made up of amino acids. And then we looked at the week before last, that presentation I gave on, histology and looking at cells and looking how proteins are created in so many different various areas of the cell. So cool to me. We want to create proteins exponentially and always, just all the time. So think about ways you can take care of yourself today in order to continue to create those proteins naturally that build the peptide bonds that tighten our skin, folks. You can think of a protein as a string of beads where each bead is an amino acid. I thought that was neat. Look at this. I thought this was cool as well. I love pictures. So the primary structure of amino acid residues, a secondary structure, a tertiary structure, and then more of a quaternary structure with assembled subunits. Just, how everything is linked and chained up together. I thought that was neat. Then, in organic chemistry, peptide synthesis or peptide production is a production of peptides, compounds where multiple amino acids are linked via amide bonds, also known as peptide bonds. So I thought that was neat to look at. Nothing you need to stress about, I promise you. But peptides are a big part of aesthetics, and we learn about them. There's oligopeptide 7, pentapeptide 5, tetrapeptide 15. There's a number more that I'm not even mentioning. There's tons out there that are synthesized in labs by scientists. And you can place them in products in order to achieve a skin tightening effect. So love, love, love that about it. Keep that in mind, that peptides are important. So it's good to understand this from some sort of a generic perspective. Then the next one is discuss fatty acids and fatty waxes. Fatty acids are a carboxylic acid consisting of a hydrocarbon chain and a terminal carboxyl group, especially any of those occurring as esters in fats and oil. So don't worry too much about this. This is just good information. A fatty wax is a simple lipids, guys, which is an ester of a long chain alcohol and a fatty acid. The alcohol may contain from 12 to 32 carbon atoms. So you might hear us talk about, what the cellular membrane is made up of, which is 2 layers of lipid with water in between. And lipids are made up of oily, waxy coatings, so that's where fatty wax is a simple lipid, it's kind of similar in that realm, nothing too concerning. So just kind of listen, don't worry too much about it, but understanding the lipid barrier is very important. And that is my last slide. So I hope you'll gain some really good information on chemistry today. Please send me 3 points that you learned, because everything in science should always circle back to the fun of why we do what we do, right? Which is the beauty industry and making products, or picking and choosing ingredients and products that actually work. And the one thing I want y'all to do is pH test everything in sight. Send me some pictures of something that you have that we can research together until we are all together again. And that'll be a lot of fun. So I hope you guys are having an awesome day and you've kind of gained some really good information. But I love you, and I hope you have a really good Tuesday, and I'll talk to you later, okay? Bye.